10.2, find arc measures. Essential question. How do you find the measure of an arc of a circle? First of all, an arc of a circle is simply a piece of the circle. So if I go ahead here and draw a circle, an arc would be a piece on the circle. And an arc has measure in degrees, and it has arc length, which is the actual length from the two endpoints of the arc. So to continue with some vocab, you have a central angle. A central angle looks like this. It deals with a circle. I've got the center point, and right here is a central angle. So it can be defined as an angle with its vertex at the center. Now, a minor arc is that piece of a circle that is less than 180 degrees in measure. So an arc less than 180 degrees. A major arc, as you would guess, would be an arc more than 180 degrees. And a semicircle, which many of you already know, is half a circle. An arc of 180 degrees, and we're going to also say that it's half the circle. Alrighty. Now, adjacent arcs are two arcs that have a common endpoint. They're kind of side-by-side arcs. So I'm going to say side by side arcs. They only share an endpoint together. Arc measure, the degree of the arc. The degree of the arc. Alrighty. Congruent circles. Well, if you think about it, triangles, we need three pieces to ensure congruency as a minimum. For a circle, we need one set of congruent pieces, and those are congruent radii. Circles with congruent radii. And remember, radii is plural for radius. Okay? Congruent arcs must have two items true in order for they themselves to be congruent. Arcs with congruent measures and congruent radii. So the circles for which the arcs come from have to be congruent as well. Now the arc measure part here is going to be highlighted in our theorem or key concept here. That's coming up here. The measure of an arc is the measure of its central angle. So what that means is if we have a circle with a center, and this central angle here is 40 degrees, this arc measure is 40 degrees. Here's an example. Now the measure of a what is 180 degrees. Now we know it's a straight angle, we're talking arcs, and this is the semicircle. Remember, half the circle. I'm going to check what we're doing on the terminology and the measurement issue, let's go ahead and do problem A1. We have to be somewhat careful here. We want to make this somewhat of an accurate sketch. So if I go ahead and put A here, straight up, B is going to be a little bit less than 90 degrees. And so this arc right here is about 70 degrees because we said it is. Now they want us to go ABC is 200, so I'm going to go across here. There's half our circle, and I need a little more here for my C here. So this part from here to here is going to be 130 because the 170 plus 130 have to add up to 200 here. Semicircle B, A, D. So since B is part of it here, I got to do a diameter here. And here's where D has to go. And again, this part here has to be 180 degrees, so this has to be 110 degrees. Continuing here, now I have to put in diameter BD, radius PA, and central angle APC. So APC is a central angle. We could figure out what the angle is, and again, what this angle is that we have the 200, we have the 230, so if I add this, this, and this, that's 310. That leaves 50 degrees here, which means that this has to be 160 degrees. They didn't ask for that, but we gave it to them. Continuing, we have a postulate here. And again, if we have a circle and we have adjacent arcs, let's say that this one is 50 degrees, and we have an adjacent arc here that's 150 degrees. And to figure out the whole total, I would just add them together. So this is just the sum of the measures of the two arcs. So if I was going to do this, this would be 200 degrees. Now with that in mind, we can answer all sorts of questions, and some will relate to some items from previous work in geometry here. So we have this figure here. I'm going to go ahead and, since we have diameters here and here, this is going to be 42 degrees. And 64 and this and 42 have to equal 180. So that means I can come up with this as being 180 minus 64 minus 42, which gives me 74 degrees. And likewise, these two here have to add up to 180. So that leaves this to be 138. And then with those central angles, those are also the arc measures. So I'll just put them out here in the arc location. And now we can simply go through these problems here. At ST is 74 degrees. QRT is from here to here to here. So I could just add up 138 plus 42 plus 74 and get 254 degrees. RSP, so RSP, that looks like a diameter of a semicircle, so that will be 180 degrees. And then QRP, so QRP means I have to go this way. It's going to be the whole circle minus that 42. So I'm going to go 360 minus 42, So that gives me 318 degrees. Now, more with this as we kind of continue, is they told us this is 90 degrees. That means this is 90 degrees. These are common radii. I could use my right isosceles and get 7 root 2 using our shortcut. Over here, A4, 90 degrees. This is a diameter. These are congruent, so I could take 180 minus 90 divided by 2 for my two pieces here. So this is 45, and this is 45. Now the question though, what is DAB's arc? Well, this is 180 plus that 45. That comes out to be 225 degrees. Continuing, the question about congruent arcs. I see that my measures are congruent, so this measure is congruent to this measure, but this is not the same as this. So no, we have different radii. We have the same measure, but different radii. Over here, if I have 90 here, 30 here, I leave 60 degrees here. Now they're asking about STV, which is 120 degrees, and then UVT, which is 150 degrees. So this will be non-congruent arcs. They have different measures, but they do have the same. They do have the same arc, at least the same radius here. The last problem here, a wheel with congruent pieces. These are all little arcs out here. So if I count them, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I got 15 sections that are congruent. 360 degrees all the way around, divided by 15 gives me 24, and this is degrees each. This is section 10-2.